in this video, we're going to look at how to sketch a graph and determine a leading coefficient and a degree if you're given the description of the graph. So we've gone in the other direction before where we've looked at a graph and described it, but it's a slightly different skill when you're looking at the description and getting the graph from that. All right, so the first thing that I would advise you to do is mark the key points that things happen. So we know something important is happening when x is less than -1 and when x is greater than 2.4, and also in between those two as well. In addition to that, we know that something is happening between -2 and 0, and we know that something important is happening after 4. And so all of those areas are areas that we want lightly marked on our graph so that we can reference them. So let's throw some numbers on the graph. So 1, 2, 3, 4. We don't need to go beyond 4, but I'll go a little beyond 4. 1, 2, 3, 4, 5. And let's do the same for the negatives. 1, 2, 3, 4, 5. All right, -1. All right, so from there, I'm going to lightly mark. So if you were working on a paper, this would be done in pencil in a very light marking. I am going to lightly mark -1.1. And this is just a sketch. Of course, it doesn't have to be entirely accurate. I'm going to mark 2.4. So that's somewhere between 2 and 3. I'm going to, and those were from here and here. I'm going to lightly mark -2. So that's from here, 0, and we have a marking at 4. So key things are happening in all of those areas. So the first thing that I would focus on here is our x-intercepts. And to figure out our x-intercepts, this is what is going to help us. When we know, all right, so the function is greater than 0, which means above the x-axis, when x is between -2 and 0. So if the function is above the x-axis, that means that those are key points, -2, -2 and 0 are key x-intercept points because we're changing from being above the x-axis to below, or we're below the x-axis to above at those points. 4 is also important as an x-intercept for the very same reason. All right, so once we have our x-intercepts marked, now we can follow here and make sure that the function is increasing and decreasing where it should be. And so the first thing is that we know the function is increasing, so it's going up when x is less than -1.1. So it's going up everywhere before there. And remember that this purple marking is an intercept. So it's going up through the x-intercept until it gets to -1.1. So let's draw that. And then it does not go up anymore. After that, it's decreasing when x is between -1.1, so between -1.1 and 2.4. And we know it has to go through that x-intercept here. So it's going down until you get to 2.4, and then it stops going down. And we know, once again, it's increasing after 2.4. So it starts to go up and it needs to go through the x-intercept. So it goes up here, and that is our graph. So now we can check in the other direction to make sure that everything is what it should be. And so checking here, the function is increasing when x is less than 1.1, -1.1. That is very true. It is decreasing in between -1.1 and 2.4. Very true. And it's increasing again after 2.4. Very true. And we can also check to make sure that the function is greater than 0 between -2 and 0. And it is, in fact, greater than the x-axis between those 2 points. And also, it should be higher than the x-axis when x is greater than 4. This is true. And it should be lower or less than 0 when x is less than 2. And it is. and also between 0 and 4. And it is. All right, so that's how we sketch the graph.